Welcome friends. Welcome to the lecture series of digital electronics. In today's lecture we are going to learn about the Karnaugh Map simplification. So how can we construct a Karnaugh Map? Previously we have some video about the rules of this Karnaugh Map. So from today we are going to learn about Karnaugh Map, how it can be constructed and what are the techniques to make a good Karnaugh map. So first of all, we are taking a simple Karnaugh map that is of only two variables, right? So first I am writing the truth table. So truth table can be written as like this. This is A, this is B, and this one is the Y, right? So in this thing, that we have 0 0 input, the output is 0. We have 0 1 input and the output will be 0, and 1 0 and the output will be 0, and 1 1 and the output will be 1. So basically we can see this truth table, that is nothing but a truth table of OR gate, right? So from this truth table we want to construct Karnaugh map. So what we need to do, that we need to make this kind of structure, right? And here you can see that there are 4 parts, right? So basically we will write over here A and write over here B. This means that all the values over here will be reflecting the B values, and all the values over here will be reflecting the A's value, right? So in this condition what we will do, 0 1, and over here 0 and 1. So now for the first case over here, this is our first case, right? So 0 0, both A and B are 0, right? On that occasion we are not getting any kind of output, so we will not write anything in this particular box, right? After that 0 1, there will be no output at the 0. See over here, this 0 reflects, that means if we get the output as 1, then we need to write over here as 1, right? But we are getting the 0, so we are not writing anything over here. For the second case, same thing, that A is 0 and the B is 1. So this one box will be also in the 0 consideration. There will be no output, right? After that, for the third case, there will be 1 as in A will be 1 and B is 0. A is 1, so here, and B is 0. So this one box will be to be filled, but there is no output. So that's why we are keeping it blank, right? After that, for the fourth case, what we are doing, that both the values are 1 1. So over here, right, and the output will be 1. So this is called as the Karnaugh map. Now rest of the blank boxes are to be filled with the zeros. So this way it can be represented, and this is called as my Karnaugh map. Now this is not over right now. Now we need to see that what kind of equation is being produced at the output terminal. So there is only 1. So if we are getting more ones, like we are getting 1 over here and 1 over here, then we need to pair it. Like pair means there are 2 quantities of 1, but it will be in this way or this way, strictly, right? After that, pairs can be allowed. Quads, if we are referring the more number of variables Karnaugh map, then it will be quads. Quads means 4 times 1s, right? This means 2 times 1. And so this kind of pairs and quads are need to be grouped. After that, if we are referring the more number of variables, then it will be octet. That means 8 ones can be in the truth table, right? So always they will not give you the truth table. They will give you some kind of this equation. This is y is equals to a bar, b bar, c bar and d bar, right? Here is the 4 variable Karnaugh map: a bar, b bar, c and d, plus a bar, b, c, d bar, and plus a, b, c bar and d bar, right? So this way we need to take this as a mean term, right? So this is our mean term. For this kind of Karnaugh map, there will be construction will be like this way, that it will be reflecting m0th term, m1 term, m2 term and m3 term from the previous video that we have understood, right? So this way it can be represented for the first particular equation, that we can reflect it like this way. Now for this Karnaugh map, we need to write this whole thing, right? This one is our one mean term, this one is our second mean term, third is our that is our third mean term, and this is our fourth mean term, right? So what we will do now, we need to construct a Karnaugh map for the 4 variables. So we have seen the things that how a 4 variable Karnaugh map can be constructed. So first we are writing like this way. If you remember the previous lecture, that I have told you to write the mean terms in a particular way. So let's understand again that this one is our AB and this one is our CD. So of these values all over here are reflecting the values of A and B, and for these values all the values are reflecting the C and D variables, right? So this way you need to write. So remembering the previous lecture, what we need to write, that 0 0 0 1 1 1 and 1 0, right? For over here we can write 0 0 0 1 1 1 and 1 0, same as that of over here. We can write these terms as, for your understanding, as an a bar b bar, right? Sorry to write over here c bar d bar. Here we can write c bar d, here we can write c d, here we can write c d bar, right? So this way it can be represented. Over here also it can be represented like a bar b bar. Here it can be represented as a bar b, here it can be represented as a b, and here it can be represented as a b bar, right? So for the sake of your understanding, I am writing this both the things. If you write any one, then it is okay, but you should know that what you have taken as an 0 and what you have taken as an 1, right? If you are referring this 0 as an bar, then you must remember this thing, and this condition we are remembering this thing, right? Okay, that the 0th term is represented as the bar term, right? So this way. So for the first equation over here, that what we are getting, that is a bar b bar and c bar d bar, right? So a bar b bar, c bar d bar. So where we can get this mean term, means this kind of condition, in which box it will be satisfied, like so you can see that a bar b bar is over here and c bar d bar is over here. So we can basically write it as 1, okay? After that, a bar b bar c d. So where we are getting this kind of condition, so over here, that is a bar b bar and c d. So that is the 1 at this particular box. After that, the third, this both we have already did. Okay, so for the third term, a bar b c d bar, a bar b c d bar over here. So we are writing as 1. So this term is also 1. And after that, a b c bar d bar, a b c bar d bar. So where we will get this thing? So over here. So this all are 1, which are basically given into the example, and in this way we can be constructing the Karnaugh map. So after this thing, what we need to do, that we need to make the pairs. But right now there are not any kind of pairs is being formed. Okay, so what we do basically, that we simply write this equation. Okay, so that's all. But if we are getting that pairs, adjacent pairs, that if this one is over here in the place of this blank box, then this both pair can be formed, right? So for that thing, we need to write the equation that a bar b bar into c d bar. Why? Because both the terms are giving the same values of 1 1, right? So our load, we can understand it like that way, that our load is being on for this both the types of inputs. Okay, here you can see this kind of input is what is this representing, that that is our a bar b bar and cd, right? For this one, we can write this thing that a b c bar d bar. For this thing, we can write as a bar b bar c bar d bar. So this way it can be represented. For example, if we are taking a smaller amount, like there are 3 variables, okay, and how a K-map can be constructed, so that we can understood like this way, that adjacent cells need to be taken, right? So if we are getting 1 over here and if we are getting 1 over here, then this 2 will be becoming a pair, right? So this way it can be represented that we need to write 1 and 1 over here. So in this next you can understood this thing, that I am taking one simple K-map that we are getting at the construction after the simplification of this given equation. You can write it as well like this way, that A over here and this one is our BC. So here we can write B bar C bar, here we can write B bar C, here we can write BC, here we can write B C bar, right? So over here and here we can write A bar and here we can write A. So there is some kind of condition is being formed like this way, that this both the values are shown as 1 1. So this both the pairs need to be formed. So this pair, how we can get this pair, then you should understand that we can write this condition like this way, that y is equals to A bar B C plus A bar B C bar. So what we are getting the common, that is A bar B, and in the bracket C plus C bar. So we are knowing the basic simplification rules of the Boolean equation, that this term is being 1, so output will be of A bar B. So this way we can get the output equation of this particular Karnaugh map, right? So this way it can be formed. Or else one more thing, that if we take one more case, that 1 1 is over here, rest of the things will be same for the condition, that A bar A B C, over here B bar C bar, over here B bar C, over here B C, and over here B C bar, right? So in this case we are getting a pair like this way. So what we need to write, that y is equals to A bar B bar C plus A B bar C So simplifying this thing, we can get the b bar c as in common. So b bar c into a bar plus a. So this term will be 1. So output will be b bar c, like this way. Y is equals to b bar c. So this technique is very much useful for the reduction of the mean terms, or we can say the simplification of the Boolean equation. So this way the Boolean equation can be simplified, right? So here you can see that these things are basically simplifying the things, and only the variables are present which are affecting the output equation. One more case, that of 4 variables, and how it can be a pair can be formed. So one more case is that if we take the same Karnaugh map, but the ones will be different, and how it can be different, let's see that we are getting one over here, we are getting one over here, a b c, and what we need to write, that a bar a, over here b bar c bar, over here b bar c, over here b c and b c bar. So here we can make a pair like this way, this one and this one. So this, both the ones are making a pair. So we can write the equation like this way, that y is equals to a b c bar for the first case over here, and I think over here, and plus a b c bar, a b bar c bar over here. So this way you can see that now we can take out some common variables, that a c bar will be taken as common, and the rest of the things will be b plus b bar. So b plus b bar is nothing but 1. So output equation will be y is equals to a c bar. So this way it can be represented. One more simplification for the 4 variable Karnaugh map. So we can let's understand that we are taking 2 cases in this particular thing. So understood it well, that what I want to say to you people, and how it can be simplified. Now this is a 4 variable Karnaugh map again. So this is our AB, this is our CD. Now what we are doing, again writing the things that we have understood, that A B bar, A bar B, A B and A B bar, like this way. And over here we are writing C D bar, C bar D, C D and the C D bar. So one more thing, that is, one is pairing over here, one is pairing over here. So this quad can be represented by this kind of method, and we can simplify this thing, right? So basically the output will be y is equals to, let's write it only, y is equals to a bar b bar c bar d plus a b bar c bar d, right? So for further simplifying this thing, we can take common as in b bar c bar d, b bar c bar d into a bar plus a. So this value will be 1, and the output will be of y is equals to b bar c bar d. So this way it can be represented. One more thing, that is the adjacent pairs can be formed like this way also. Just understand this thing and assume the rest of the variables that we are writing in the previous methods, right? So this one is AB and CD. We can write this as C bar D bar. We can write this C bar D. We can write this CD, and we can write this CD bar. Here we can write A bar B bar. Here we can write A bar B, A B and A B bar, right? So this way, in this condition, what we are getting, that for this all the things we are getting 1. So in this whole thing we are getting a common output. So further simplifying this equation, we will get y is equals to a b bar into c bar plus c, again the same values, and the output will be only of y is equals to a b bar. So for the rest of the simplification you need to do it at your own. Now you are getting the things that how this can be achieved, right? So this is the thing. One more thing that we need to understand, that is our Groupism technique. That is second technique of particular equation of the four adjacent variables. So here we can see that this thing is in horizontal condition, but if we are getting all the ones in vertical condition, then it can also be simplified, right? So this way you need to understand. Now furthermore simplification we are doing in the next particular page. So let's understand that this is our four variable Karnaugh map, right? In this condition what we are doing, again we are writing the things a, b and c, d, right? So a for the a bar and c d bar, a bar over here, b bar, c bar, d bar, c bar, d, c, d and c, d bar, right? Over here we can write a bar, b bar, a bar, b, a, b and a, b bar. So this way, if we are getting all the ones over here, then we can also simplify the thing, and this is a quad, right? This is called as a quad. So this is a pair of the four ones, and we can further simplify this thing, and we can get this thing as in y is equals to b c bar if we simplify this thing by just conventional method and take out as in common. One more thing, that if we take this kind of Karnaugh map, there are some ones in particular this condition. Understand it well, otherwise you will not get anything for this Karnaugh map, that this way and this way. So it is assumed like this way, that both are as in circular motion and this are getting paired with each other, right? So this is also called as a quad, and for this we can also simplify the condition. One more case will be like this way, that in this condition we are getting the ones at all the four corners, over here, over here, over here and over here. So this way it can also be represented, and the pair can be formed 1 1 1, right? And for this all the ones we can write the equation. This is also called as the quad. Why? Because all the fours are getting a pair of with each other, right? So it will be this way. In the all the four corners are being met at one particular point that we are getting in this case. One more case is like that, that if we take a Karnaugh map this way, the Karnaugh map we are taking, and both the ones are over here. So this way also it can be formed a quad pair, and we can write the equation. This one is also the example of a quad. So this way it can be represented. One more case, that we can also overlap the group is, right? How it can be overlapped? So let's understand that thing. For the condition, we can make a 6 pair, or we can 3 pairs at a single Karnaugh map. So this way there are 4 quads, you can say. This one quad, the second quad is being formed over here. So this is one quad, and this pair is being paired over here. So for all the pairs we need to simplify the equation. So basically if we write the equation, for this pair, the output will be of y is equals to bc plus bd plus a bar b c bar. So this way it can be represented, right? And the last but not the least, the last case is that we are getting the octalate, right? So in octalate conditions, we can pair it like this way, that we are getting ones in this particular form. This all are 1, this all are 1, and this whole group is called as the octalate, right? There are some cases, if they can ask you for this kind of particular cases, then it can be shown like this way, or it can be also in the horizontal condition and vertical condition, or it can be also possible like this way, that some force are at this venue and other force are at this particular condition. Then in this way also octalate can be formed, right? So this way octalate can be shown and paired. So this is how the K-map simplification, or we can say Karnaugh map simplification, can be done. So that's all for the Karnaugh map, and this way we can understood the Karnaugh map in very well condition. So we have taken one example in this particular video, and we can basically denote it, or we can say solve it the particular way. So there are one more thing, that is whenever they will ask you in the exam, they will ask you in this way, that y is equals to sigma. Now sigma represents the sum of product form, and if they will provide you sigma as an particular equation, sigma m, and they will write some variables 1, 5, 7, 9, 11, 13 and 15. So this is a condition of 4 variables. Why? Because if you remember the previous lecture, so if there are 4 variables, then the output will be of 2 raised to 4. That means 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 2s are 32. So there are 32 cases, but in the condition of this particular equation, there will be of 16 values. So this way it can be represented, right? So for the 16 value minterms, there are 16 minterms in this particular equation. For sigma m, this way I have taught. But right now, if they provide you like this way, that pi m, so the pi represents the product of sum. So whenever you write up the things, so you need to basically remember these things for the product of sums and for the sum of products. So they will provide you some variables over here also, and you need to basically construct a Karnaugh map for this values. So this way it can be represented, and that's all for the Karnaugh map. For the further examples, we will refer to the next video. If you have understood this thing, and if you have gained some of your knowledge, then you must like and share my video, and if you want to watch more this kind of videos, then do subscribe to my channel. Thank you.